All right, this is Team 1 presenting our Operating Systems final project. We are Jesse Shellabarger, Josh Woods, Mohammad Almisbaa, and Tayler Howe. For this class, we've created a bare metal operating system with the ability to read, write, and modify its files, run 16-bit C programs, that also features multitasking and round-robin scheduling. To start off demonstrating our file system, if we run the dir command, it will display all files and programs currently in the system, as well as the number of sectors they're occupying. We can run the create command to create a new file. Let's call it test1. And then the OS will prompt us for input, so just give it a couple lines of contents. And then we can enter a new line to indicate that we are done. If we run the dir command again, we can see a new file has appeared called test1. We can also run the type command on test1, and it will print out the contents of that file to us. We have another file manipulation command, copy, which will copy the contents of one file to a new file. If the second file doesn't exist, it will create it for us. Let's run the directory again. You can see that test2 is now shown up. If we type test2, we can see that its contents are the same as test1. Let's run our delete command and get rid of this new file we made. As you can see, it's no longer on the operating system. On to program execution. We can use our execute command, execute, to, still didn't spell it right, execute command to run programs that have previously been written. So let's run test program 2. It should print a line back to us. And there we go. We also have the ability to multitask and run multiple programs at the same time, and the round-robin scheduler will switch between these programs. So I'm going to run a program that prints foo indefinitely, and then I'll run one that prints bar indefinitely, and then I'll freeze the emulator to show that they are indeed printing in chunks. So let's execute foo, there it goes printing. Then if we execute bar, and then freeze the emulator, we can see that we have alternating blocks of foo and bar, and foo and bar. And so the round-robin scheduling is kicking each one off of the processor to schedule the other one. If we reset our emulator, we can show the rest. We have a execute in foreground command in order to run a program and halt the shell while that program runs. So we've got a phello command, or a program to print out hello world a bunch of times. And while it does this, the shell will not run anymore, so it cannot take any more commands. And then just hit enter again to get our shell prompt back. And let's do that again. And I'll demonstrate that our kill command we can use to kill any given process. We just give it the process number. We can get the process number by running our print table command, which returns to us 3 columns. The first row is the process number. The second row is A for active, if that process is currently meaningful, I for inactive. And then the third column represents the stack pointer, F for the default, and X for anything else. So I will run execute phello again, and then kill 1 to get it to stop. So execute phello, and then I'll kill 1, and you can see that it stopped midway through its execution. In terms of bonus features, we have the print table command that I've shown. It prints out the current representation of the process table. We also have a help command to display a short user guide with a list of commands and how to use them. We have also implemented a change background command, change BG, which will change the background of the emulator window. We can use R for red, B for blue, or G for green. Change BG with any other command will then change it back to black. Thank you.